Okay, so today we're starting a very important section for Math 2. We're going to learn how to factor a trinomial. We already factored by finding the GCF, but factoring trinomials are very important. You guys should all, that's my goal. Nobody can get out of this class until they know how to factor a trinomial properly. Okay, so we will continue to go over and over this all year long. Okay, so this is your first example, first intro to it. So you might not be great at it at the beginning, but by the end, you will know how to factor if it kills me. Okay, so what we have done so far is multiply using our box. Okay, so we're going to just practice multiplying and just remember how we multiply because it'll help us with how to factor. So this is 2x minus 3, and this is 3x plus 4. Okay, Lily, what do I do first?
I'm trying to look for a measurable.
Okay, you're looking for, find the notes for us. That's the homework packet. So excited. Okay, Piper, you tell me. What am I going to do first here?
Find the GCF.
No GCF here. How do I multiply this?
Multiply 3x and 2x.
Very good. Multiply this times this to get the area of this little square. 6x squared. Okay. Stephen, what would I do next? Okay, the negative 3 times the 3x to get the area of this square, which gives me negative 9x. Then I continue and do this 2x times this 4 to get 8 x's. And then finally I'd multiply the negative 3 times the positive 4 to get negative 12. Now, I've added this circle, so it's easy for us to combine these two like terms. And we're just going to stick them. Once I've combined them, then I stick that answer in the middle. So negative 9 and positive 8, they're opposite signs. So I'm going to subtract and get negative 1x. Now the area of this whole figure is the 6x squared minus the x minus 12. That's the area of this figure. Okay. You can also see the area right through the diagonal. Does that make sense? Okay, I don't think we need to multiply another one. I think we got that. So now we're going to work backwards. If you notice in our original problem, I was given the length of the sides, and then I had to fill in the box to find the area. In our new problem, I'm giving you the area, and what I'm wanting you to find now would be the length of the sides. So our area is the x squared minus 14x plus 33, and that goes where our area went before, which is in this diagonal. Okay. Now I don't have the area of this box or the area of this box, but I do have the area of these two. So I'm going to use those two to help me find the length of the sides. Now I know that I had to multiply this length times this width to get the x squared. So what multiplies to x squared, class? X times x. This one's easy because there's only one thing. X times x is the only thing that's going to give me x squared. Then I'm going to do the same thing here. What times what will give me that 33? Okay, 11. So this side would be 11, which goes up here, and this side would be 3, which would go here. Now if you switch the 11 and 3, it'd still work out. You'd be fine. Okay. Let's check now. We want to check to make sure these side lengths work. We need to get negative 14x somehow. So let's check this area. 11 times x is 11x. And x times 3 is 3x. This is an addition sign. That means I'm adding. If I add 11 and 3, do I get a negative 14? No. But what if I add negative 11 and negative 3? Would I get a negative 14? Yes. Okay, so remember, if this is negative, then this 3 needs to be negative. If this 11 is negative, then this 11 is negative. Okay, because it's like we're factoring out that GCF like we did yesterday. That first term is negative, so this side length needs to be negative. So our factors are x minus 11 and then x minus 3. Any questions over that? We're all good? Okay. Now I'm going to make you guys help me out here. You guys have a blank page on the back of your notes. I'm going to have you do this on this side because I want to give you lots of room because we're going to have to probably play around with this a little bit. Okay, and I want us to be able to have a lot of room so you can write down the steps I'm doing. And I don't have enough room on this. So on that blank page, write down the 4x squared plus 7x plus 3 and draw the box like it has. Okay, so this is 4x squared goes here, 7x, and positive 3. Okay, the first thing we're going to do, okay, you do that first term here, in that top left-hand corner of the box, and we want to find out what multiplies to that. Then go what multiplies to 4x squared? Okay, 2x times 2x. Is there something else, class? Yep. 4x and 1x. Okay. So you're just going to pick one. We're going to start with the 2x and the 2x to see if that works. Then step 2, what multiplies to 3? That last box. In class, what is that? 1 times 3. There's nothing else, right? So we'll put a 1 and a 3 here. Okay, so our third step now is to check. And check to see if the middle term would be 7x. So if I did 1 times 2x, I'd get 2x. And then if I did 2x times 3, what would I get? 6x. This is a plus, so if I add those, do I get 7? No. Okay, so now we're gonna try again. If it doesn't work, try again. Okay. So that was our first attempt. It didn't work out. And it won't always work out. Sometimes we're going to have to erase and try again. I'm going to make you guys draw the box again, just so you can see all the attempts we made. So this is 4x squared, 7x. This is 3. Okay, so from step 4, we're going to go back to step 1. What multiplies with the 4x squared? 2x and 2x didn't work, right? So we're going to try now the 4x times the x. Okay. Then we go to step 2 again. Is there anything else that multiplies to 3? No, just 1 and 1. So we're going to go back to 1 and 3. Now we're going to go to step 3 again, check to see if that would work. Okay, so this would be 1 times x would give me 1x. And then 4x times 3 gives me 12x. Again, if I add them, if I add 12 and 1, do I get 7? No, we got to try something else. Okay, so we've already tried the 2x and the 4x, okay? The only other thing I could do is switch 1 and 3. Or you could switch the 4 and the x. Whichever one you choose is fine. So I'm going to draw my box again. Please bear with me as you take really good notes so that when you get home, you remember how to do this. I have my 4x squared, 7x, and positive 3. I'm going to keep the 4x and the x where they were. And now I'm just going to switch. I'm going to put the 3 here and the 1 here. And let's check that one now. So 3 times x is 3x. And 4 times 1 is 4x. Yes. If I add 3 and 4, do I get 7? Yes. The 4 is positive, so the 1 is positive. The 3 is positive, so the 3 is positive. So my factors are 4x plus 3 times x plus 1. Or you could have it the other way. X plus 1 times 4x plus 3. Any questions over that? We're good. Okay. So I know I drew that out and made a big process of it, but I wanted to make sure you had all the steps down. So if you get stuck on something, you can keep going. Okay, not all of them will take that many tries. Some of them might take more. It just depends. Okay, so let's try our next one. No, we're gonna go back into here. So go back to F. We're gonna put C, last page of notes. So you can go back and remember that's where you took that, that's where you went over that one. And we wrote out all of our steps. Okay, I want you guys in your pairs to try F. Okay, so this is x squared, 3x, and negative 28. X and X, and lots of you came with 4 and 7. And again, if you have the 4 and the 7 in different location, it's still okay. This gave me 4x. This gave me 7x. Now, because this is a negative, you're subtracting. So one of these two terms has to be negative. Okay, and then we determine which one's going to be negative to make this a positive 3. Is it the 4 or the 7? The 4 needs to be negative. If that 4 is negative, then this 4 is negative. If this 7 is positive, then this 7 is also positive. So your factors are x plus 7 and x minus 4. Any questions over that? Okay, let's do the next one. Okay, Maddie, what multiplies to 6? Okay. So this is 2a and this is 3a. Xavier, what multiplies to 35? G.
35. I put on top -7.
And 5. We're not worried about the signs yet. We'll check them. Okay. So let's check. 7 times 3 is 21. And then 2 times 5 is 10a. Again, this is negative, so we're subtracting. One of these two needs to be negative. Which one's going to be negative to give me a positive 11? This 10's negative, so that makes the 5 negative. The 21 is positive to get this positive. So we have 2a plus 7 and then 3a minus 5. Any questions over that? Okay, we're going to skip H and go to I. Okay, so for 12, there's 2 things that multiply to, well, 3 things that multiply to 12. You can have 1 times 12, 2 times 6, and what else? 3 times 4. Okay, Samantha, what do you want to choose first? 1 times 12? Okay. Y times 12y. See if that works. For 20, we have 1 times 20, 2 times 10, and then 4 times 5. Juan, what do you want to choose for that one? 4 times 5. Let's try 4 times 5. So let's check this. 4 times 12 is 48y, right? And then y times 5 is 5y. Is that going to work? No. Okay, so now we're going to switch this. If I put the 5 here, is that going to get any better? And 4 here? No, it's going to actually make it worse. So the 12, let's try something else. Let's go. Blake, what numbers do you want to choose for 4 times 3? Sasha, what do you want to do for the 20? What multiplies the 20? 2 and 10? Okay, 2 times 3 is 6y, and 4 times 10 is 40y. Is that getting any closer? Nope. Okay, let's erase those and try to put the 2 here, or the 10 here, and the 2 here. I'm going to give you a little trick. If 4y and 10, they're both divisible by 2. Okay? When you're factoring, you should never have your 2 terms in your binomial or in one of the sides that are divisible by the same number. It won't work. Okay? So instead of having to keep guessing and checking it, having to check it all the time, if 4 and 10 are divisible by 2, they're both divisible by 2, they don't go together. Okay? If they were both divisible by 3, they don't go together. Okay? So don't try it. So let's pick another one. Which is another option? What? 1 and 20? Okay, can I put the 1 here and the 20 here? Oh, that's going to make it even worse, right? That's going to be 80 and 3. Okay. What else? 4 and 5. Okay, let's review what I just said. Can I put the 4 here? Right, then these 2 terms will both be divisible by 4. Will that work? No, so that 4 cannot go there. The 4 might be able to go here, and the 5 can go here. Let's check that. 5 times 3 is 15y. And 4y times 4 is 16y. Oh, goodness. Yay. Okay, again, I'm subtracting, so one of them needs to be negative. Yep. Okay, the 16 is going to be negative here. Will that give me a positive y? No. So this one has to be positive, and the 15 needs to be negative. Because 16 minus 15 is a positive 1y. So this 15 is negative, and the 14 is positive. Any questions? So my factors are 3y plus 4 times 4y minus 5. How are we doing? Good? Okay. On the back. And then we're skip J and go to K because it's a little bit more difficult. So 4x squared minus 20xy, 25y squared. Okay, class, what multiplies to 4? 2x and 2x. And then class, what multiplies to 25? 5. Okay, because the 25 has a y, you have to have a y on the 5 this time. The others we've been doing only have one variable. This one has 2. So both of your terms and your length of your sides need to have a variable. Let's check it. 5 times 2 is 10y, or xy, sorry. xy. And 2 times 5 is also 10xy. Now, since I'm adding, they both need to have the same sign. So if they're both negative 10s, will I get negative 20? 10 and 10 is 20. Okay, so the 5 is negative, and this 5 is also negative. Oh, look at that, they match exactly. When the lengths of the sides match, what type of shape is that? A square. So this is a square. So I can write 2x minus 5y squared, since the length of the sides match. Okay, any questions over that? Okay, next one. That's weird. I only have 2 terms there. Okay, so there's a 9b squared goes here. But where does that negative 49 go? Okay, do you think it goes in the circle? Bottom right. The circle is reserved for just the b's. How many b's do I have here? I have b squared, but just b. How many just b's there? Is there 1? There's none, right? And what does none mean in math? 0. So here I have 0 b's. That middle term should cancel out. Okay, so you need to put a star on this because there's quite a few problems in your homework that are missing that middle term. The middle term cancels out, becomes 0. And so you need to remember how to put it into the box. 0, it's 0. Yeah, yes, like, oh, yes. Sorry, I didn't know. Okay, let's go and, okay, class, what multiplies to 9? 3b and 3b. And then class, what multiplies to 49? 7 and 7. Okay, so let's check this. Good, yeah. So this will give me 7 times 3 is 21b. And then 3 times 7 is 21b as well. I'm subtracting, so one of them needs to be negative. In this case, does it matter which one's going to be negative? No, so you can make whichever one you want to be negative. So this is a negative 7, this is a positive 7. Do these match exactly? No, they're close but not exact. So you have to write it out 3b plus 7 and 3b minus 7. So this is not a square. This is very close to a square but not a square. Any questions over that? Okay, let's try M. So we have 4x squared minus 4x plus 1. Check what multiplies to 4x squared. Good. Class, what multiplies to 1? 1 and 1, right? So then we multiply. 1 times 2 is 2x's. 2 times 1 is 2x's. I'm adding them. That means they both need to have the same sign. So to get a -4, I need them both to be negative. So this becomes -1 and -1. So we get 2x minus 1 times 2x minus 1. Any questions over that? Okay, next one. Okay, what multiplies to 9? 3c and 3c. And what multiplies to 2? 2 and 1. This is 6c. This is 3c. If I add them, do I get -5? No, I don't, right? If I switch the 2 and the 2, 2 and the 1, will that change anything? No. Is there anything else that multiplies to 9? What else? 9 times 1. Let's try 9 times 1. 9 times 1. Oh, and then what am I missing? I need the C's, right? Okay. This is 2C. This is 9C. If I add, will I get -5? No. Okay, I can switch the 2 and the 1. See if that works. Will that work? Have I missed anything? Okay, when something is only divisible by itself, what do we call that? Prime. I think you might have 2 prime in your whole homework. So if you end up with like 7 of them, okay, we're not going to be okay with that, okay? So don't just keep saying everything's prime, because it's not. There's 2 of them, I think. Maybe 3. Can't remember. But for sure, not 5 or 6. Okay, try O. Remember, O is just like L or I. What is that? JKL, like L. So that should be our answer for O. Any questions? Okay. The area of a rectangle is x squared plus 5x plus 6. What is the length and the width of the rectangle? Okay, it's asking you the same thing, just in a little different way. So it's asking you to factor. So you're just going to use the box. They gave you the area. They want you to find the length and the width. So this is x squared, 5x, and 6. Okay, Rihanna, what'd you get? X plus 3 times X plus 2. Thank you. So I kept hearing something different. Okay, those should be our factors. Any questions? Okay, this one's trying to trick you. It's trying to make the same thing complicated. It's saying if 3x plus p and x plus q are factors of 3x squared plus 13x plus 4, which of the following must be true? Well, let's check. We're going to put in our box. I have 3x squared, I have 13x, and I have 14. They're saying that the length of my sides are 3x plus p and x plus q. So let's fill in the missing pieces. P times x should be px. And 3x times q is 3qx. So what should be true? So you guys decide. P, is it A, B, C, or D? Oh. Any ideas? Yes. C and Y.
Times Q, and you get 3Q, and X times P equals Q.
Very good. Okay. The px and the 3q, they should be combining to get that middle term of 13x, right? So C just takes away the x, and P plus 3q should give me that middle term of 13. I know. You will. If it's in your homework, or if it's in your notes and your homework, it could appear on your quizzes. There we go. Okay, because again, that px plus 3qx should equal 13x, right? This is the same as this, they just left off the x, right? That's the only difference. Because these two things should combine to that middle term. Any questions over that? Okay.